Hello, my name is Diego Cruz, and this is my lab 4 for Physics 2211. So, a quick table of contents of what this lab is going to consist of. It's going to be an introduction slash purpose, plus the laws that are used in this experiment, the experiment itself and the procedure with that, the data and code with the results of those, and then errors, and then conclusions and what ifs. So an introduction and purpose. So just a bit of introduction. This lab is about looking at the oscillation and like movement of a spring mass system with that spring. Like it's like the end of a spring oscillating. And so the software we use to track that is Tracker. And then we're going to later use coding with GlowScript, which is a Python software. And then the laws and formulas we use in this are Newton's second law, which is F equals ma, but we use the formation of delta P over delta T, which is change in momentum over change in time. And then we use the energy principle, which says the energy of the system is equal to the work of the surroundings plus a change in internal energy. And then we use a position update formula and the velocity update formula. And so the experiment itself is we use Tracker to plot the position of the end of the spring mass here. And then we said that mass was around zero point 0.5 kilograms, 0.05 kilograms. Um, and then we set L equal to zero point 0.7 meters. So that's that stick here, that length here. And then we used it to track this position here using a frame by frame analysis. And so the code itself. Um, we set the system mass, and then we set the initial positions using what we had in Tracker. And then skipping a bunch of these lines, we got to gravity constant, which we know, the spring constant, which was given, and the relaxed length. And so we were able to use the length of that the spring. Um, and then L hat is just going to be like the unit vector of that. Um, and yeah. And so these bottom four lines are going to be used to find energy, so certain energy. So this is kinetic energy. So it's 1/2 times mass times velocity squared. And then this is U grav, which is the mass of the ball times gravity times the Y position. And then this is the spring, which is 1/2 Ks squared. And then the total is all of those combined. And so the next thing we did was we made a loop. So ours went for 9.4 seconds. So we had a loop that establishes the initial energies, and then it was going to go through and update those energies as the time goes. So as you can just see here, we just have a couple lines of code that calculate net force. And so we update that spring with force, and we use the change in energy, like theorems, we use E equals, the theorem mentioned before, which was the energy of the work of the surroundings plus a change in internal energy. And so that's basically what this is doing here. It's going to change those energies and then on tell us what E is at the end here. And then delta E will be the E at the end here minus the E at the initial that we found at the start, which was mentioned here at the bottom E. And so what that basically did is it's going to just tell us the change in those specific energies over time. And so this blue one here, the small one, is a change in kinetic energy. This red one here is a change in potential gravitational energy. And then the green one is change in spring potential energy. And then the orange one is a change in energy. And so as you can see here, the change in energy is pretty much zero. And so what that means is that it kind of worked. So the system and the mass were one system. So it makes sense for the energy to not change because we weren't adding anything else into the system as we were going through. And so the results here continued. This is the exposition versus time. So as you can see, we have a model versus experiment, and those were really aligned. So that worked out really well. So that did well. And then Y position, on the other hand, they were kind of like inverses of one another. So as our experiment went down and up and down and up and down and up, our model went up and then down. So that didn't go as well. Maybe I don't know how that happened, but it just did. And then some possible errors. There could have been a multitude of errors, but some of the more common ones are probably the tracking. So we probably could have messed up when it came to tracking the center of mass of the object. Coding itself could have went wrong itself. So we had a bunch of errors in code that we had to go through multiple times with our TA. So definitely could have happened there. And then human mistakes when it comes to just making errors and anything else that we could have thought of. So final thing, conclusion and what ifs. So the spring mass, the I guess the conclusion is the mass spring system shows energy shifting between kinetic and potential energy, which is grav and spring potential energy, keeping the total energy almost constant, which makes sense because as I mentioned before, this system is a combined system. So there's nothing else acting on the system. So it makes sense for the change in the system to be zero. And then lastly, a what if is what if there was a bigger, like an actual like mass cube or something attached to the spring? So if we were to add that mass, it would kind of create oscillations if we were to just pull the spring down and up. So here in this video, the guy was pulling it left to right or whatever. He like started it as like a pendulum, but if he were to just add the mass on the bottom and then just pull the string down with that mass, it would have created oscillations, allowing energy to transfer between kinetic and potential forms. And then the heavier the mass, that slower oscillation would have occurred. Thank you.